Okay, next I'm going to do the 2007 AP Calculus question number 3. All right, this is a table question, and table questions are very common on the AP Calc exam. All right, for your Chapter 5 test, we have not really learned much about antiderivatives yet. We've kind of touched on it, but we haven't really gone into depth on it. And Part C is a fundamental theorem of calculus question, which involves antiderivatives. So I would not ask you Part C. Okay, Part A says, explain why there must be a value of r between 1 and 3 so that h of r is equal to -5. All right, usually when you say there must be a value of something between two different values, you kind of want to think about what the endpoints are. So let's think about what h of 1 would be and h of 3. Okay, so h of 1 would be f of g of 1 minus 6. So I'd have f of, work from the outside, or from the inside out. So g of 1, so look at x is 1, g of 1 is 2, minus 6. F of 2 is 9. So 9 minus 6 is 3. Okay, and then h of 3 is f of g of 3 minus 6, so follow the same pattern. So g of 3 was 4. So I have f of 4 minus 6. F of 4 is -1. So -1 minus 6 is -7. Okay, so what this means is we have some kind of function. It's differentiable everywhere, therefore it has to be continuous everywhere. So we have some kind of function, and at 1, I drew this kind of backwards. We'll just go down like that. And 3, we have these two values. So in order to somehow connect those two values, so some kind of function that connects them, we had to cross every single y value between them. Okay, this is called the intermediate value theorem. So we had to cross -5. So -5 is somewhere between them. So we say yes, since h is continuous. It's continuous because it's a composition of continuous functions, because they're differentiable. So since h is continuous, there exists a value r on 1 to 3, so on that interval, where h of r is equal to -5 by the IVT. Okay, so this could have been any number between 3 and -7. Okay, intermediate value theorem. B, explain why there must be a value such that h prime of c is equal to -5. Okay, this is a little bit different. All right, again, we're going to look at the endpoints. So if I had h of 1 and h of 3, and we're talking about the slope. Okay, this is a little bit harder. Let me think. Let me go ahead and sketch it out. This may make more sense. So if I have 1 and I have 3, and 1 was at 3, and 3 was at -7, and we can combine them. So we're going to somehow combine them with some kind of function. Okay, if you guys remember the theorem we talked about in class, if we have some kind of function, and it's continuous, and it's differentiable everywhere, there has to be a place where the derivative is exactly equal to this connecting the two lines. Okay, that's what it's saying. So we want h prime of c to equal, well, is that -5? So let's see. So if I do h of 3 minus h of 1, all over 3 minus 1, I get -7 minus 3 over 3 minus 1, so -10 over 2, so -5. Okay, this slope is -5. So is there a place where we have that exact same slope? Yes, there has to be. So we've learned that, and that is called the mean value theorem. So since h is continuous and differentiable on that open interval, there exists a value C such that h prime of C equals -5 by the mean value theorem. So you can call it the MVT. Okay. Part C, like I said, we wouldn't do. So part D says if G inverse is the inverse function of G, write an equation for the line tangent to the graph of G inverse at x equals 2. Okay, so this is actually interesting because in class I told you that I rarely ever saw this formula. So I was surprised in this question that I had it. So that's one of the reasons I gave it to you for your review. So if you guys remember, if I talked about G inverse prime of 2, so that's the slope at 2. Okay, we had a theorem in class that I told you was very rare. So it would be G prime of G inverse of 2. So remember, I told you the way to memorize this is you can just flip these and then do 1 over. Okay, and basically what this is saying is that if we had inverse functions, it's hard to draw, so they're reflected across the line y equals x, for these points, if this slope was 3/4, this one would be 4/3. They're reciprocal slopes. Okay, so that's where that theorem's coming from. All right, anyway. So I have 1 over G prime of G inverse of 2. So what does that mean? That means when we have G, we want to plug in an x value and get 2 out, so that when I have x equals 2, I get something out. So go back to your original graph. It's kind of hard to see. And we want to find when we get 2 out in the G function. So we get 2 out when x equals 1. So when I plug in 1, we get 2. So when I plug in 2 into the inverse, I get 1. So I have 1 over G prime of 1, so go back to your original. And G prime of 1 is 5. So your slope is 1/5. And it's at x equals 2. So that point for G inverse, if I had x equals 2, let me think. That was the thing that gave you 2, remember? So that was 1.
Okay, how much I need this for?
All right, so that means that we have 2, 1. All right, and our slope was 1/5. So I have y minus 1 equals 1/5 times x minus 2. Okay, and that's your answer. Okay, so that was a tricky one. So like I said, that's very rare that it's on the AP Calc exam, but I was very surprised that that was on there, so I wanted to make sure you guys saw that example.